Here is my audience. Oh my God. Hi, my name is Brian Garfield, and today we will be going over some comparisons of using superchargers and turbochargers in internal combustion engines. Why are superchargers and turbochargers used in different practices when they both provide forced induction? Forced induction is used in many engines, especially in current times. It's used to improve efficiency. An engine is limited by many things to include displacement, volumetric efficiency, fuel utilized, materials used, performance, and reliability. Turbodiesels are all the rage these days, but superchargers have been around longer and have reliability and simplicity advantages. Improving performance in internal combustion engines while lowering emissions are paramount in the automotive field. Superchargers provide an exponential and passive increase in effective induction, while superchargers provide an immediate and fixed increase in effective induction. Why is forced induction used? Forced induction is used when a naturally aspirated engine is not enough for the application. Termed boosted, forced induction began being utilized in military applications, industrial work, and high-performance engine building in the early 20th century for internal combustion. Airplanes needed to maximize power while reducing weight in flight. Tanks had to increase torque and still fit the engine within the vehicle. Superchargers were the first form of boost to be used on internal combustion engines. People found that using an air pump driven off of an engine to cram more air in than the atmosphere can provide increased power and torque without increasing displacement. Superchargers are used in top fuel dragsters in their most competitive use, and turbochargers have become a staple in the diesel and gasoline engines used for maximum efficiency and displacement. What requirements are there for turbo versus supercharged applications? Well, they have to cram more air in than the atmosphere can provide, increase power and torque without increasing displacement, and superchargers specifically are always creating a parasitic draw on the engine and are a simple way to compress air. Turbochargers became mainstream in the 20th century and are composed of two turbines coupled on a shaft enclosed in individual housings. The concept of charged air, cooled by turbo expansion, applied to internal combustion engines was developed in the 50s and 60s. How is it managed? In forced induction applications, power is managed by a throttle body in gasoline engines and by fuel metering in diesel engines. Supercharged outputs are dependent on their size and mechanical ratio of rotation relative to the engine. Turbocharged outputs are dependent on their size, base-specific fuel consumption, engine displacement, fuel type, and wastegate systems. A turbocharger provides a delayed response from full load to full load because cylinder pressures need to increase naturally to spool the turbo and therefore increase cylinder pressures. Superchargers provide an immediate response from low to full load. As cylinder pressures increase, power output reaches its maximum for that RPM. When is it needed? Turbos tend to outperform crank-driven superchargers in fuel economy tests that determine efficiency ratings for new vehicles. The use of a turbocharger alone at low engine speeds, on the other hand, is inefficient and results in higher nitrous oxide emissions due to high intake temperatures. Superchargers provide a constant and fixed rate parasitic draw on the engine's output, increasing base-specific fuel consumption and decreasing efficiency at low RPM and low load. Superchargers, however, are generally more inexpensive to maintain and provide immediate throttle response due to being physically locked to the engine rotationally. Superchargers also provide the benefit of simplicity because they rarely require pressurized oiling or cooling to function reliably. In small displacement vehicles that focus on efficiency and larger diesel vehicles that are required to move large amounts of weight over long distances for long periods of time, turbochargers are generally the best option. They are the most efficient at low RPM and low load, where those vehicles will likely live out most of their lives. Superchargers are most efficient in extremely high-performing gasoline engines when maximum efficiency is not the main concern due to their immediate response and simplicity. This also provides an increase in reliability. Turbochargers provide an exponential and passive increase in effective induction, while superchargers provide an immediate and fixed increase in effective induction.